Thank you. So I'm going to present some results, mainly geochronology and some geochemistry from our Mary Kathleen Domain study. There was a magma fertility focus to the study, but I'll just come into that towards the end. Thank you. I'd like to thank GSQ for their support for this project and funding for this project. I'd also like to thank the landowners that gave us access during our field work. So I'm going to summarise some of the results. We ended up with 137 samples that we did whole rock geochemistry from, 30 samples of zircon geochronology. Now that's just the samples that we could get decent ages from. We did test more samples than that. I'm not going to talk about the garnet geochronology, but that is included in the report. We did some thin section petrography of quite a few samples there. Now, due to COVID, our fieldwork, or part of our fieldwork, was delayed a bit. So that gave me an opportunity to put together a spreadsheet of all the Mount Isa igneous rock, major and trace element geochemistry that I could find through other databases, literature, and various theses as well. I've talked about that database in previous talks, so I'm not really going to cover that today. So I'm going to take you through our sample locations, first moving from north through to south, and we've already been introduced to the Mary Kathleen Domain from the previous talks, so I'll just quickly go through where we got our samples from. So starting towards the north, this is just east of the Dougal River area, and we sampled some various intrusions in that area, and I'll come back to all these sample locations when I go through the geochronology. We also had samples from the Mount Godkin igneous province, including the main granite body. We took some samples from the pegmatite as well, and also this smaller intrusive body just to the southwest there, and that's quite a complex body. It's mapped quite simply, but it really comprises a lot of different phases, ranging from these monzonites, diorites as well. We sampled throughout the Wonga granite to the west of the Birstall granite there, and then various samples from the Birstall granite area, including the Lunch Creek gabbro, and various intrusions found throughout the Mary Kathleen syncline. And then right down in the southern area here in the Greens Creek area, which I'll go into shortly. Further samples came from Overlander and Revenue granites, and then also a detailed study of the Myobe igneous complex, and this has been done by one of our PhD students, Joshua Spence. And then we went further south. We sampled from the Mount Earl igneous complex. I'm not going to talk about that too much today, but then grabbed some samples from around the Plum Mountain area and south of that Plum Mountain fault. So sampling that what's mapped as the Birdswell granite, and we grabbed one sample of the One Tree granite as well to the south there. So I'm going to go through all these locations again and go through the geochronology results. And some of this data has been touched upon in Joanne's talk, and some of it's also very similar to what Dave's talked about as well, but I'll focus on a couple of key outcomes there. So our youngest ages came from our group in the north. So we had some ages around that 1500 mark, and then we had one sample that was a bit older at that 1746. So we had a younger age from, this was an intrusion that's intruded into Corella Formation. And we had samples of the Mavis granite diorite and some other unnamed intrusions there. These ages are similar to what's been done before in that area, with the one exception of this age here. So this unit is mapped as the Dipfale granodiorite, so the same as this unit a bit further south here, but it's thrown up a younger age there. So various ways to interpret that. So maybe this unit is not actually the same as this one to the south, or we've sampled a younger intrusive phase that we haven't been able to distinguish through field relationships, or that our zircons are throwing up some sort of younger event. But I think it's more likely that we've either sampled some other younger intrusion within that, or that this unit is not actually the same as this one further to the south. Okay, into the Mount Godkin area now. So not really any surprises with the ages that we got there, except that there was a bit of separation of the ages. So this main part of the granite body to the north and to the east had those slightly younger ages there. There's actually a fault running through here, and then this body or part of the intrusion there has thrown up an older age there, and that's actually consistent with the GSQ result from another sample from a very similar location there. So there could be, this could be actually a different phase compared to this larger mapped area here. And we also had one sample that we got a good age from that complex just to the south there, and it's a slightly older age. So I'm now going to go through the Wonga and Birstall granite area ages. Again, most of those ages are similar to what we'd expect. So looking at the Birstall granite, sort of Lunch Creek Gabbro area, and some of the intrusive phases in that Mary Kathleen syncline. The ages broadly split into two groups, sort of a 1740 to 1750 kind of ages, and then a younger one at about 1723 to 1725. And then into the Wonga, again, no surprises with those ages there, except for this one right down at the bottom, the Greens Creek sample. So Joanne's already talked briefly about that sample. There has been previous published ages of Greens Creek samples taken from the west of the road heading south there, and those ages are of Wonga and Argilla type ages. Our samples have come from east of that road heading south there in a different creek platform, but part of the same area. It's mapped as Argilla formation, but it's throwing up a much older age of basement age. Into the Revenue, Overland and Maiubi complexes. Again, ages standard with those sort of Wonga Birstall sweet ages. The Maiubi one, the age reflects or matches some of those younger phases, slightly younger phases in the Birstall area. And the next one I'm going to get into is south of the Plum Mountain Fault. So you'll see here that there's quite a high uncertainty on this age. It's based on, I think, about 5 zircon results, but we tried to date quite a few of our samples in this area, but this is the only one that gave a reasonable age. And again, a much older age, which is consistent with other data that we've got that Joanne's presented, and also what Dave presented from the areas that are mapped the same, but just north of this Plum Mountain Fault area. And from previous studies from one of our PhD students working on this Tick Hill area, these old ages are really consistent with the old ages that they're getting in that area, and you can see those down here, so that really most of those are those old basement ages. We've done a bit of Titanite geochronology. Now, this wasn't included in the report because we've had a student working on this more recently. So all our samples that we could get the Titanite ages from, predominantly those ages were about the 1500 mark for most of the samples. But we did have some groupings reflecting older events as well. So from similar ages to what we get for the zircons, and then younger ages after that. And I've just got 2 samples here to highlight that. So this was our slightly older sample from that northern area, that zircon age about 1746, and then you can see the titanite age sitting here about 1500. Here's our really old Greens Creek sample, about 1862 or so for the zircon age, and again our titanite population is giving an age just slightly older than that 1500 mark as well. So really reflecting some of those younger events that are affecting some of these older samples. So I'm going to talk very briefly about petrography. Quite interesting being out in the field and seeing some of the relationships here. So our samples range from, we took a few of the mafic samples, so mafic sort of amphibolitic type compositions through to gabbros and into diorites, and we got a couple of dolerites as well. Then we had some that were more monzonite, monzodiorite like compositions, and then through into our granitoids, or our more felsic granitoids, granodiorite granites and cyanogranites. We had almost all the samples have phaneritic textures through to porphyritic phaneritic textures, and various degrees of foliation development in those rocks reflecting different types of metamorphic strain on these samples. One really interesting thing, and this was particularly evident in that Birstall region, but we did see it in some other locations as well, is evidence for magma mingling. So we got some really, you can see those photos on the right, some really beautiful textures showing magma mingling of that more felsic phase and a more mafic phase together. Standard mineralogy for our more felsic granitoids were quartz, at least 2 feldspars for most of the samples, and then bitite or hornblende, and some samples had both bitite and hornblende in them. Accessory phases include titanite, apatite, zircon, calcite, fluorite, and then also we had varying degrees of magnetite. So some samples would return a hand magnet signal and others didn't. The samples variably altered, and alteration was mostly chlorite and sericite alteration, and then some of our more gabbroic samples we had a replacement of pyroxenes. And we also had these interesting micrographic textures and showing in quite a few of our granite samples that intergrowth between potassium feldspar and quartz. I'm not going to dwell on the geochemistry too much, apart from really that a lot of the data overlaps with amongst all the different samples studied, and this has been repeated before as well. And one thing to note was that the aluminium's not especially high. So if you had high aluminium values, it would indicate perhaps more delayed saturation of plagioclase and perhaps elevated water concentrations in your magmas, but we've got lower aluminium values for most of the samples, and suggest that plagioclase is playing a strong role during magmatic evolution of these samples. And some trace elements here, again, there's more variation within individual plutons and across suites than amongst them. So a lot of overlap with the data, and you see this if you put all the felsic data together from right across the Mount Isa and Lyre, that you get the same sort of patterns as well. So yeah, just a taste of some of the trace elements. And here I've just thrown the rare earth elements in for completion, and you'll note that yeah, it's a bit of a busy diagram, but you can see that the predominance of those negative europium anomalies throughout the granitoid and felsic intrusions of the Mary Kathleen Domain. I'm going to talk a little bit about the magma fertility now. Now, when we think about magma fertility with these sort of more felsic rocks, and we turn to the literature and we look at all the magma fertility studies that are related to the porphyry systems, and then we try and make sense of that with what we've got. So it's not surprising that our data doesn't fall into that fertile zones, because it's all related to rocks that come from classic arc settings of Phanerozoic ages, and relating to these porphyry copper deposits. And obviously our rocks are not within that scope there. But one thing to note is that within those, for example, the Chilean porphyry copper deposits, within the suites that are associated with those porphyry copper deposits, you do get granites in similar phases that plot in that barren area. They might not be directly related to those porphyry systems, but they're within a suite that through magmatic evolution is broadly related to it. So you can get these barren intrusions that have just tend to follow a more plagioclase dominant fractionation trend, whereas the ones that are associated with the fertile compositions tend to be more of a hornblende dominant fractionation trend. So it's not surprising that our samples fall in that low strontium yttrium ratios, and that's typical of these Proterozoic granites, and that's been reported in our literature before. We have to remember that our granites are much older. They have this, the geochemistry gives off this arc signature, but those arc signatures are derived from looking at much younger arc rocks. We could be getting that signature through reworking of older crust as well. So we can't definitely say that it is a sort of Proterozoic arc-like setting. Our granites, our Mary Kathleen Domain samples tend to plot in the I-type field, but very close to those A-type boundaries. And if you look at the Mount Isa region, regional granites, you tend to get compositions that plot across that I-type into A-type compositions. And we didn't do the looking at the relative oxidation for our particular samples, but I have done it for the Mount Isa granites across the region, and the majority of them fall into that sort of more oxidized field. Okay, just finished with a summary that our geochronology reveals several locations where our samples are throwing up older igneous ages, so older than the way that they are currently mapped or grouped into suites. And so we share the same conclusion as GSQ, that these groupings of intrusions into the igneous suites requires a bit of revision in certain areas. There's abundant evidence for magma mingling and multiple phases of igneous activity at single outcrop locations. And so that's something that I'd like to investigate a little bit more, that role of felsic and mafic magmas together. Geochemically, there's more variation within individual plutons and across suites than if you compare them against each other, and that our intrusions tend to plot in the non-fertile regions of these classic magma fertility diagrams, but we have to be very aware that these diagrams are based on very different systems than our own, and we're looking at samples that might be related or perhaps related to our IOCG family of deposits. So different again, we've got such a range of different deposits here, rather than just looking at one singular type. So I'll finish up there. We can get to morning tea.
Thanks, Helen. Right on time. Yeah, we do have some questions. Elena?
Interesting data. And I was just wondering about your data on zircon and titanite. Some of the titanite show very close age to zircons and some quite much younger. What is your interpretation and thoughts about these different titanite ages? Do they reflect very close or much later metamorphic event, or this is rather the reflection when they're close of the cooling temperature?
I think for most of the samples, we're seeing the reflection of later events. The ones where we've got the Titanite ages that are close to the zircon ones, in those populations, there are the younger Titanites as well. So we're getting that broad spectrum, or we're getting them all much younger.
It would be interesting. I think you have some appetite to see what the appetite would give you. And in these cases where the age close, you may check the possibility of the cooling history of the granites. Would be interesting. Did you think to follow it up with
yes, we've got quite abundant appetite in many of the samples. So that's another avenue to go down.
Okay, thank you.
That was a very nice presentation, the geochronology. Really enjoyed that. I have a question for you. In the Mary Kathleen area, I showed yesterday the very significant elevation in nickel, and cobalt, and copper. Those rocks also have elevated scandium, which is suggestive of a mafic and ultramafic source. Do you think that that could reflect the process of magma mingling that you were alluding to previously, to then explain the possible relationship between your ideas of the granitoids and the clearly different geochemical signature that would be generated by a granitoid source?
Yeah, so we tend to see that bimodal distribution, but there are a lot of samples that fall in the intermediate part, and often those, it looks like it could be a reflection of some mixing between a more mafic and felsic source. Yeah, and you often see those in the same area where you've got a mafic and felsic intrusions. Yeah.
There are some questions appearing online. Well, actually, a lot of them are just comments, but one question. Thank you, Helen. You mentioned the intrusives in the Mary Kathleen domain are oxidized, but relatively dry, plage saturation. How does this affect sulfide saturation in the intrusives, i.e., are they sulfide saturated? Do you think there is potential for some of the metals to have been sourced from these intrusives?
I haven't really looked into sulfide saturation in detail, but based on my previous work with sulfide saturation with porphyry systems, you can get some sulfide saturation occurring, but you're still able to form a copper deposit. So just because you have sulfide saturation doesn't restrict you to not forming a deposit, but it might change the ratios and metals you get in the deposit. But it's something I haven't looked into in great detail.
Yeah, there's another question in the chat that I can actually answer, which is, have all the geochronology results been compiled in a database and released? I should have mentioned this earlier, but all of the reports associated with the JCU work and with our GSQ work are available on the GSQ Open Data Portal, and some of the data sets are available and others will be available as soon as I get my act together, because you've sent them to me but I haven't got them up on the portal yet. So they'll be available very soon.
Helen, with this bimodal distribution, have you tried to sort of model, the link or isotopically, or just model, whether these two groups are connected, and whether there is any, I think sulfur has been asked, but are there any sort of connectivity between them, to result in better magma fertility?
And so one thing I'd like to get into next year is doing the different isotopes for the samples. I haven't been able to do that yet, but that is something that I'm going to look at, particularly where you've got those mafic and felsic pairs together, and that reoccurs right throughout the Mary Kathleen domain. In quite a few locations you get those pairs together, so that's something I'd like to look at, is the isotope signature for those mafic felsic pairs and how related they really are.
Thank you.